these properties so many times before in all of your classes. But, so Travis, you need to make sure you have these properties written down. Bradford, make sure you have these properties written down. And I'm just going to give you an example of something that you may or may not see. So make sure you have these properties written down. I'm going to give you an example that goes along with each of them. Okay? So properties with imaginary numbers. Is there any property up there that you already know, you recognize, we do it all the time, we use it? Give me one. It's the distributive property. Okay? So I agree. We know what that one says. So what would an example look like that would go with the distributive property? Let me scroll down here. When I say the distributive property, it means something like this. What if I had a 3 on the outside and I had like a complex number on the inside? 2 plus 4i. How could I use the distributive property in a complex number? What would I do with it?
You multiply to the 2 and the 4i.
Perfect. So what would that be? 6 plus 12i. I mean, like, it's that easy, right? On the SOL, it's going to say identify the properties listed in each of these steps. So that's exactly what you're going to have to do. So I'm kind of going the other way. I'm telling you what the property is, and we're giving you an example. But we're going to have to go the other direction. If I gave you the example, could you identify that as distributive property? Would you be able to recognize it that way? Good. And that's what you're going to do on your test next week. Okay? So are there any others up here that you've seen 100 times, and you know what property it is? The distributive one we use all the time. The others, we don't really use those all the time. Or at least we don't name them. Anybody else remember? How about the commutative property? What would that look like? Well, if I have, let's do the same thing, 2 plus 4i, the commutative property says that I can just reverse the order in which I add things. So 4i plus 2. Right. The commutative property just means that the order that you add things doesn't matter. Okay, so make sure that you're adding the example along with each of these, okay? Now, commutative and associative are always taught together for some odd reason. What does associative mean? I always like to say it's what you associate. It usually has parentheses. It should always have parentheses. But commutative property can have parentheses too. So be careful with that. The associative property just means what's inside the parentheses is different. So what you are associating is different. So for example, if I had 2 plus 4i plus 3, notice where the parentheses are right now. If I'm going to change, I'm going to put something different in the parentheses, I might put what I would combine. So 2 plus 3 plus 4i. That would be an example of the associative property. What you are associating, what's inside the parentheses, is different. Okay? So again, you need to be able to look at those examples and recognize, oh, that's a commutative property, that's the associative property, and go from there. Identity and inverse. Do you know the difference? Anybody from algebra? It's been a while, probably. Did you do the properties in AMPAO? Was it you took it? No, probably not. I'm just asking. I know we didn't do many of them in geometry. I don't know, and I know you did in Algebra 1, but that was a while ago, right? Okay, the identity is simply what you can add or multiply that won't change anything. So think about multiplication. What can I multiply something by that won't change it? What number can I multiply? 1. If I multiply anything by 1, I get the same thing out, right? So the 1 is the multiplicative identity. That's like the whole big way to say it. The identity of multiplication. So if, for example, if I had 3i times 1, I'm still going to get 3i out. Would you agree? That is the multiplicative identity. Okay? There's also an additive identity, one that goes with addition. What number can I add to something and it won't change its value? So we already know these. So if I had, for example, 2 plus 4i plus 0, what should I get out? 2 plus 4i. Would you agree with that? So if I take a complex number like 2 plus 4i and I add 0 to it, it doesn't change the value. So the additive identity is just 0. Now, the for multiplication. It's two numbers I multiply, and I get the identity out. Same thing with the addition one. I think the addition one's a little easier. It's two numbers I add together, and I get the identity out. So what two numbers can I add together, and I equal 0? So for example, if I had 2i here, what could I add to it and end up with 0 at the end? Negative 2i. Very good. So basically, the inverse of a number is just the number with its opposite sign. Okay? So an additive inverse is simply just the opposite sign of the number. When you add them together, you get 0. That's the identity, right? Same thing with multiplication. What can I multiply? Two numbers I can multiply, and I want to get 1 out. Because 1 is the identity for multiplication. So what can I put in? Let's say I have, let's make a number up, 4i here. What can I multiply by 4i that will give me 1 at the end? Not negative. Negative is the additive. The opposite sign is for the addition one. When I multiply, it's called the reciprocal. Do you remember that? When you multiply something by its reciprocal, you get 1. So it'd be, what is the reciprocal of that? 1 over 4i. Would you agree? If I multiply those two things, I would get 1 out. So I know that you have done all of these properties up to this point, up to number 7. You've seen them before. We just don't use them very often, use the names. So I understand it, forget when you're here. I get it. Sometimes I have to look it up too. All right, number 8, closure. This is probably a new one for us. So I'm going to explain it first, and then we'll talk about how to give an example of it. Closure is when I do, I'm going to start with addition. Okay, closure is when I can add two kinds of numbers that are alike. So let's talk about whole numbers. Give me an example of a whole number. What are they?
5.
5 is a whole number. 6 is a whole number. 7, 8, 9. What's the smallest whole number? 0. So 0, 1, 2, 3, 4, 5. If I take any two whole numbers and I add them together, will I get a whole number out? Yes. Whole number plus whole number equals whole number. Would you agree with that?
Yes.
That means that whole numbers have closure. Okay? Let's do integers. Are integers the same way? What are integers?
Really?
-1, -3, 1, 2, 5, 100, -7,000. Those are all integers. If I take two integers and I add them together, will I get an integer out? Yes, so integers have closure as well. Let's think about imaginary numbers. Okay? If I take imaginary numbers and I add them together, will I get an imaginary number out?
Yes.
Here's an example of that. I would take 3i plus 2i. So I have an imaginary number. Which is an imaginary number, right? So it has closure. Okay? So that's what closure means. Okay? Two things added together, I get the same kind of number out. Okay? So those are your properties. You will have to identify them. And I hate to say the word memorize, but unfortunately that's kind of where we're at. And we're going to need to memorize those. Those will be on Tuesday's test. Okay? Now, go ahead and get that quiz out for me. It's not really a quiz, but it's your homework that I gave you on modeling and systems. Is modeling, let's make sure we know what's on the test. Okay? So on Tuesday's test, we have modeling is going to be on there.
That's Tuesday we go back.
Tuesday you come back. So I did say I would stay after on Monday. So for review, if you want to come Monday after school, I'll be here. We have modeling. We have quadratic systems. And when I say systems, you have to solve it a couple of different ways. We can solve it by graphing, and we can solve it by substitution. And Taylor made a point. She's actually right. On the back, I gave you room. I didn't say how to solve, but I wanted you to solve a substitution back there. Okay? So graphing and substitution. By the way, we have several people who still need their OPQ on that substitution. So if we have time today, you can take it if you want. Okay? On quadratic systems modeling, you also have complex numbers, kind of like the cross number puzzle, being able to do that. And then the last thing is the properties. So properties of I. Oh, with the complex numbers, I'm going to put patterns of I, because that wasn't on the crossover puzzle. But remember, like I to the 300th power, do you know how to come up with that solution? I is an imaginary number. It's just that's what it is. I mean, you can actually graph it on a complex plane. I could go into a lot of detail, but I was way above that. So just imaginary number. Okay, that's what we're gonna say. So all of this is going to be on your test. This quiz I gave you, okay, is just a little review of the first two, of modeling and quadratic systems. So this is only your review for the first. You still have to make sure you know your properties and how to add, subtract, multiply, divide complex numbers and patterns of I. Okay? Let's look at this quiz here. I'm going to turn a light on because I know it's a little sleepy in here. Do you have any questions on it? Is there anyone you want to go over? We're going to go over the calculator steps and the modeling stuff again? What do you want here? Is there enough left?
For the model?
For the original. Yeah. Okay. So can we do I think number 2, did I tell you that the answer was not there to number 2?
Yeah.
Cross those out, okay? So you have to come up with your own answer to number 2. So let's make sure we know how to do that. Okay? So in number 2, it says you threw a rock over a balcony overlooking your backyard. The table shows the height over some different times. We want to find a model. So I'm just going to go ahead and write the table here. So time versus height. And I'm actually going to add a couple of questions because these are the kinds of questions you'll see on your test. Okay? So we have at 0 seconds it was 16 feet high. At 1 second it was 36.3 feet high. 2 feet was 47.2 feet high. At 3 feet, it was 7. At 4 seconds, it was 20.8. And 5 seconds was 23.5. All right, so let's just go through and remind ourselves the calculator steps on how I do that. So let me go get my calculator out. So if you remember, we're going to go to stat, what? Type in the values. Edit. Good. So stat edit. Enter. And I want to type it in. So I have 0. Enter. 1. Enter. Just enter in all of the time values. I want you to do this too because I'm going to add some questions. So I want everybody to be typing it in. So Bradford and Travis, make sure that you have your calculator out. I'm going to add some questions to it. Let's type it in, just like you see it. Nope, you can leave that on all the time. It doesn't matter. So now I'm going to type in the height of the rock that I threw. Let's just type it all in. All right, so once I have the values in, okay, what do I do with the information now? I'm trying to find, I think it says on the question, it says model, right? Where do I go from here?
You are stat plot?
Not yet. If I wanted to graph it, sure. Then we can get there. If we want to graph it, we go to stat plot, which is second y equals. We want to make sure that it's turned on, and it is. And then we probably want to, I don't know what we want to do, change our window, right? X goes from 0 to 5, y goes from 16 to, I don't know. Sometimes you can just, if I do a standard window, I won't see any of the values because the y's are way too high, right? So maybe if I zoom stat, sometimes that's an option, and it will kind of fit it really good. Oh, flip it back a bit. Second y equals. You're going to turn it on. Okay, so I now have a picture of the points. I want the model, the other word for model is equation. Exactly. So I got it. How do I get that? Stat, calc. Very good. So I'm going to go to stat and over to calc. And I'm going to go down to quad regression. Because it does look like an upside down parabola, doesn't it, to you when I look at those points? And I hit enter. List 1, list 2, that's where I put all the information, so that's right. And then I calculate. And it gives me an equation. Okay? So this is the equation that I want to type into my calculator. So negative 4.7x squared. Go ahead and type it in to the y equals. Go to y equals and type it in. You want it to graph right on top of those points.
So how did you get the equals? Stat count?
stack calc,
That's what I
and
did.
then go down to quad reg. This is the quadratic regression. So negative 4.7x squared plus 25x plus 16. I'm just going to type it in.
So negative 4.7?
Yep, that's what it said. 25x, and then was it 16? Okay. And I'm just going to graph it, and hopefully it graphs right on top of those points, and it did. Awesome. So that was the equation. I think I remember I told you on the actual quiz part, there wasn't an actual answer, so we'll type it in ourselves. On your test, Tuesday, not only will you have to find the model, but I'm going to ask you some questions. So here's what I want you to do. The first question I'm going to ask you is, what is the maximum height of the rock? So let's write that one down. I might write it down on your paper too, because that's going to be a study guide. What did I do to answer that question, right? So question number 1 is going to be, what is the maximum height of the rock? How high did that rock go? How can I use my graph to answer the question? I went to stack, calc, quad reg.
Yeah, I did that.
Okay, so what's your question then?
Which is why?
The numbers I got from the stack, calc, quad reg. You have to plug it in. All right. How do I answer the question? What is the maximum height of the rock? Where do I go to do it? What do I use? Huh? I calculate what? The maximum. That's what I'm going to do. So I'm going to go ahead and calculate the second calc. And I'm going to calculate the maximum. The maximum is the highest point. I'm going to go to the left of it, to the right of it. It's going to ask us those questions. So I'm just going to move this little flasher guy to the left. I'm going to move that little flasher guy to the right. And hit enter. Guesses and enter. My question is, which one of those two numbers am I using? The 2.6 or the 48? You have to go to zoom stack. Which one? Which number am I using? The 49. The height is the y value. So 49.24. I think we said feet, right? Please don't round that to a whole number, okay? Just give me 2 means of decimal. Two decimal places is a good thing. The second question I might ask you is, when did the rock hit the ground? That's the second question. When did the rock hit the ground? How can I use the graph to answer that question? What should I do? Well, there's no minimum. But and honestly, my graph doesn't show it real well. So I'm going to change my window, and I want the y min to be like a negative number. Let's just do negative 10, just so you can see what I'm talking about. Now maybe you can answer the question a little better. When did the rock hit the ground? Well, somewhere down here, but I can't see it. So I have to adjust my window to make it more to the right. So I'm going to make my x's go more to the right. So if I go to my window, I want my x max to be bigger than 5.5. I don't know, what do you think, 8? Does that work? Let's try it. So what I'm looking for is when it hits the ground. Do you see where it hits the ground right now? As long as you can see it, we can find it. What is this thing called right here? A 0. So I'm going to go to stack calc and calculate the 0 as well. And this is where I have to go on either side of that 0. So I'm going to go on one side to the left, hit enter, second calc 0. And then we go on either side of it. When did the rock hit the ground? At 5.9 seconds. That's what the calculator told me. So what I'm going to tell you is that if you want extra practice on the properties, page 15 in your textbook, problem, I think it's 38 to 45 or something like that. The numbers, I'm not going to officially assign it for you, but I will tell you it'll be extra credit on your test if you want to do it. It's the properties, so that is extra credit. Let me just double check on the numbers to make sure it's 38 to 45. But that's going to be something I want you guys to do to practice with the properties. Let me double check the It's 35 to 40, sorry. 35 to 40 are the properties. So that's, I'm officially assigning that as extra credit. 35 to 40. Those are your properties, and then that's really all I'm going to assign, okay? Because you have to practice for this test, you got to study. I have your cross number puzzles. I'll give those back to you today, and then you can take your OPQ if you want. That's going to be the rest.